Hey there, students. I used to do this a lot last year and in previous years. For those of you who were with me last year, you'll remember. For those of you who weren't, it's a way for me to work with you and do some instruction with you even when I'm not there. So just sit back, watch, listen, and if there's something that I do that confuses you, you can ask Ms. Martinez to pause, and then you can ask either her or your peers what I did or why I did it. And then Ms. Martinez will start the video again. So what I'm looking at right here are the two equations that we worked on. We did this, trying to remember, I think last week. I want to say maybe last Friday. This is what we did when we were in Mr. McGuire's room. So I'm just going to get started and I think you'll recognize it, okay? Over here, I added x to this side and I added x to that side. And a negative x and a positive x canceled out. And I was left with 3y equals. Now, I can't add these. I can't add 3 cell phones and a bagel. So I just have 3 cell phones and a bagel. Now when I say a bagel, we know that means I have 1 bagel. So I can put a 1 there and that's perfectly fine. So what do? I divide by 3, I divide by 3, I divide by 3. These check out because 3 divided by 3 is 1. These check out because 3 divided by 3 is 1 plus 1/3. Oh, sorry, that's an x. Sorry about that. 1/3 x. Okay, now 1y is just a y. 1 bagel is just a bagel. So I got y equals 1 plus 1/3 x. And we're looking good there. Well, I'm looking good all the time, but we're looking good there. Alright, so let's do the other one. I'll change colors here. I'm going to subtract 4x, subtract 4x. I'm just going to thin that out a little bit. These check out, and I got 3y equals 18 minus 4x. This is like 18 burgers minus 4 books. You can't do that. You can't subtract books from burgers. Divide by 3, divide by 3, divide by 3. These check out. I'm not even going to write the 1y. I'm not going to write the same thing that I wrote over here. I'm just going to put y equals 6 minus 4 over 3x. So hopefully you remember this from the other day. We worked on this in Mr. McGuire's class. We all graphed this. Okay, and let's take this and put it onto this slide, and let's take this and put it onto this slide, and here we are. So I'm going to graph both of these, and since I have 2 different colors, I will graph them in 2 different colors. Remember, I got to put y and x. Alright, so this one goes up to 1, and then from there goes up 1 to the right 3. Up 1 to the right 3, up 1 to the right 3. I can keep going as long as I want. See if I have a blue line here. I do. Gotta fix that a little bit. Yeah, it's good enough. Okay, so this one starts at 6. 1, 2, 3, 4, 5, 6. And it goes down 4 over 3. Down 4, 1, 2, 3, 4 over 1, 2, 3. 1, 2, 3, 4. 3. Okay, and let's see if we have a red line. I believe we do. Alright, looking good, looking good. And wait, there's a... Okay, whatever. All right, so what we talked about the other day, the big important thing that we were trying to get at was that this point right here, that point right there, is the only point that is on both lines. And that point is 1, 2, 3, 1, 2. That point is 3, 2. Remember, I count x first and then y. All right. So that point is 3, 2. It's the only point that is on both lines. This point's on the blue line. This point's on the blue line. This point's on the red line. This point's on the red line. That point's on neither line. This one is the only point that's on both lines. The only one. So if I were to go back to here, do some erasing, and put the point 3, 2 in, negative 3 plus 6 is 3 equals 3. That's true. And then if I were to put it in over here, four times 3 is 12, plus 3 times 2 is 6. 12 plus 6 is 18. Because this point is on both lines, when I put that point, 3, 2, into both equations, they're both true. That's how it works. That's how it works. And you'll also remember that I worked with both equations to get this. I worked with both equations to get that. And that's something that I'm going to work on now. I had this. So I'm just going to use a bag of potatoes. Here's why. Let's just say randomly, okay, I'm making this up randomly. Let's say y is a bag of potatoes. Whatever, I'm just making stuff up. Let's say y is a bag of potatoes. Well, if y equals this stuff, what does this stuff also have to be? This stuff also has to be a bag of potatoes. Otherwise, they wouldn't be equal. A bag of potatoes can only equal a bag of potatoes. A bag of potatoes cannot equal a bag of bananas. It doesn't work. So remember, I said y was a bag of potatoes. So what's y? A bag of potatoes. And if y equals this stuff, what does this stuff have to be? A bag of potatoes. And you're like, Eckert, that's great, but why are you doing this? Well, let me show you. This stuff right here, this bag of potatoes right here, has to also equal this bag of potatoes right here. Because a bag of potatoes has to equal a bag of potatoes. And so what I'm going to do is I'm going to take this bag of potatoes and show that it's equal to this bag of potatoes. Why am I doing that? Hang on, it's going to take the screen a little while to get there. Why am I doing that? Because now that I made this bag of potatoes equal to that bag of potatoes, I only have one variable. I only have x. So I'm going to figure out what x equals. Let me switch the pen. Subtract 1, subtract 1. 1 minus 1 is 0. I'm left with 1/3 x equals 6 minus 1 is 5 minus 4/3 x. Okay, I'm going to add 4/3 x because I'm trying to solve for x. Those check out. And I got 5 equals, let's see, 1/3 x plus 4/3 x equals 1 plus 4, 5/3 x. Let me move that up a little bit in case you want to see that. Okay, so the easiest way to get rid of a fraction over here is to multiply by its reciprocal times 3/5. Got to do it on this side also. Let's see what happens. 3/5 times 5/3 x. 5 times 3, 15. 3 times 5, 15. Still got the x. 15/15 cancels. What am I left with? X. Another way that you can cancel is this. Cancel the 5's, cancel the 3's. So let's do it over here. 5 and 5 cancel. What am I left with? 3/1, which is just 3. X equals 3. X equals 3. I did all that work and I got x equals 3. Well, let's looky here. X equals 3. So without graphing, I was able to figure out the x point where they intersect without graphing. I was able to do it all using algebra. This is all using algebra, just moving variables around, solving for variables that we don't know. I was able to figure out what x equals simply by using algebra. Now that I know that x equals 3, I can just take x equals 3 and put it into either equation and figure out what y equals. Okay, y equals 1 plus, let's see, this is really 3/1, so these cancel. And I've got 1/1, which equals 1. Y equals 2. Let's see, this is really 3/1, so the 3 and the 3 cancel, and I'm left with 4/1. 4/1, which is really 6 minus 4. Y equals 2. Either way, I get y equals 2, and look what we got here. Y equals 2. There it is. There it is. So I just want to review what I did. Okay, I just want to talk about what I did. Okay, so I took the equations, put them in y equals form. Then since y is a bag of potatoes, everything y equals is also a bag of potatoes. So I just made the bag of potatoes, the bags of potatoes equal each other. And then solved for x. Once I had x, I just plugged back in to get y. How easy is that? So that's what you're going to work on today. All right? And I'm going to end the video with this still showing. Okay? And that way, as you work on this throughout the rest of the day, you can remember that that's what you do. You take the equations, you put them in y equals form. Since y is a bag of potatoes, everything that y equals is also a bag of potatoes. So you just make the stuff that y equals equal to each other. Then you solve for x. Once you have x, you plug back in and you get y. The graph was just to show you that what I did was correct. You will be doing no graphing today. You'll be using all algebra to solve for x and y. Good luck. I miss you guys. and I'll see you tomorrow.